Hello chemistry students and welcome to lesson 4.05. In this lesson we are going to cover the fifth and final reaction that we're going to study in this chemistry class, and that is combustion. Now in doing so we are going to cover some common core standards that we have, and you can read these standards in more detail in the course if you go to course information and scroll down to standards, and then you can pull these up and read them in more detail. For this particular lesson, we are going to first identify combustion reactions from examples. We're then going to identify the properties of combustion reactions, and then finally we're going to predict the products produced by those combustion reactions. So let's go ahead and jump right into it. First thing, we need to just quickly remind you that we do want to have some background knowledge, so we want to make sure we understand lesson 3.05, dealing with ionic compounds, 3.06, dealing with covalent compounds, and then finally 3.08, naming compounds. It's very important to be able to do these things to identify which compounds we have, be able to name them and write their formulas, so that we do have a successful experience going through the lesson 4.05. If you're still not comfortable with those lessons, please go back and review them. It is going to help you throughout Module 4 and Module 5. Also be sure that you understand lesson 4.02, where we are balancing reactions, because again we will be balancing quite a bit in this particular assignment. So if you, again, are not feeling comfortable with those lessons, please go back and review them. You can watch the videos that are available, and you can also attend the tutoring sessions if need be before you attempt to do 4.05. So what is combustion? Well, combustion is simply when a compound or element reacts with oxygen, and then it releases a large amount of energy, usually in the form of heat and light. Now, because it is releasing heat, combustion reactions are considered to be endothermic. And again, the key component here when we are trying to identify them is that oxygen is one of the reactants, and we're always giving off heat. Those are the two main things that we're looking for. If oxygen's a reactant and we're giving off heat, then we have a combustion reaction. Now there's a couple different types of combustion reactions that we can have. The first type is when we are burning organic compounds called hydrocarbons. A hydrocarbon is simply a compound that contains both carbon and hydrogen. Now whenever we burn a hydrocarbon, the neat thing with these is that we get the same products every single time. And those products are going to be carbon dioxide and water. An example is one we just placed down here, the burning of propane. And I'm sure probably many of you have gas grills and know about propane. We use that when we are cooking. Well, with the propane, it has a formula of C3H8, and if we're combusting it, that means the other reactant has to be oxygen. So we got the O2. The products are now going to be CO2 and H2O. So of course then we would have to balance this. So if we had 3 carbons on the left side, that's why we put the 3 over here on the right in front of CO2 to give us 3 carbons. So now we have 3 carbons on both sides. Now we look at the hydrogens. For the hydrogen we have 8 on the left. To begin with, on the right there is only 2. So if we place the 4 in front, 4 times 2 gives us 8 hydrogens on the right side. And then for the oxygens, this one is actually easier if we start on the right side. We got 3 times 2, so that's 6 oxygens. And then over here we got in the water 4 times 1, so there's 4 oxygens here and 6 in the CO2. So if we add them together, we get a grand total of 10 oxygens. So on the right side, or excuse me, on the left side, we also need 10. So if we put a 5 in front, we have 5 times 2, That gives us our 10 oxygens on the left side. So this would be the balanced equation for the burning of propane. And again, this is when we have a hydrocarbon, a compound containing carbon and hydrogen, combusting with oxygen. We always end up with carbon dioxide and water for our products. Now the other type of combustion we can have is when we are dealing with inorganic compounds. Okay, so an organic has carbon, inorganic does not have carbon. All right, and these are compounds and elements that do not contain carbon and hydrogen. They can also burn in oxygen. A lot of times these reactions can also be categorized as synthesis reactions, which we'll show you here in a moment. But it can also, again, be considered combustion because one of the reactants is oxygen, and they release energy. The example we wrote in here is a great example for this. We take hydrogen gas, H2, plus O2. They would combine together to make H2O. Well, because we have two substances combining together to make one, we do have a synthesis reaction. But because one of the reactants is oxygen, and this reaction releases energy, it can also be considered exothermic. So again, we do need to balance it. Originally we have two H's on the left, over on the right two, so they're okay. What it is though is the oxygens. We have two oxygens on the left and O2. There's only one on the right. So by putting the 2 in front, now we got 2 times 1 to give us our 2 oxygens. But that 2 also changes the hydrogen. So we had 2 times 2, there's 4 hydrogens. So on the left side we'll need a 2 in front to give us 4 hydrogens on this side. So again, because this is highly exothermic, it is a combustion reaction, and we actually are using hydrogen as a fuel in certain situations. And this is where you may have heard of hydrogen fuel cells, where they're trying to use this on a more broader scale. And of course that leads to the whole field of alternative fuel sources. And just a side note that is one of the ones that we're looking at, is using hydrogen as a fuel source. All right, so let's look at some sample problems. First one here asked us to write the balanced equation for the combustion of methane. All right, well, when we're writing balanced equations, first we gotta kind of get the information we need here. Combustion means that the other reactant has to be oxygen. Methane is a hydrocarbon. Therefore, the products must be CO2 and H2O. So when we put that all together, we have CH4 plus the O2 yields CO2 plus H2O. This is our skeletal equation. Then we need to balance that. All right, now we have 1 carbon on the left of the arrow and 1 on the right. So that's fine. We have 4 hydrogen on the right, only 2 on, on the left, and only 2 on the right. So if we put a 2 in front of the H2O, that balances the hydrogens. Okay, so that's what we got down here in the bottom, 2H2O. Again, that will affect the oxygens. So we got 2 times 1, 2 oxygens. Over here we got O2. So total we have 4 oxygens on the right side. To get 4 on the left side, then we had to put the 2 in front of the O2. So we have 2 O2. Oh, I'm sorry, we got another sample problem. Then we'll do a couple together. All right, for this one, we have to write the balanced equation for the combustion of potassium. Well, again, because it is combustion, that tells us the other reactant is oxygen. Potassium is an element, therefore we treat it like a synthesis reaction and not a hydrocarbon. So we got K for potassium plus the oxygen yields K2O. Now that K2O we get from K having a +1 charge and oxygen having a -2 charge. All right, remember those are the two common ions. So when we do the crisscross method, that 2 becomes the subscript behind the K, and this 1 becomes a subscript behind the O. So that's where we get K2O from. All right, remember that's what we learned back in 3.05 in that assignment. So now we have to balance. If we only have 2 Ks on, or excuse me, let's start with the oxygens. We have 2 O's on the left. We only have 1 on the right. So we need to put a 2 over here in front of K2O. Now, because we put a 2 here, that of course will change the K. So 2 times 2 gives us 4 Ks. So we'd have to put a 4 on the left side. And that's where we get this balanced equation of 4K plus O2 yields 2K2O. All right, so let's try a couple together here. First one, write the balanced equation for the combustion of butane. Go ahead and take a moment and pause the video and try to work that one out for yourself. Alright, so again, because we have butane, C4H10, we have a hydrocarbon. Combustion means we are combining it with oxygen. Our products, whenever we do combustion of a hydrocarbon, is going to be CO2 and water. All right, so if we go back over here, we got 4 carbon on the left. That means we're going to need 4 carbon on the right. We got 10 hydrogen on the left. So to get 10 on the right, we need to put a 5 in front of the H2O. Now we have a little problem here because that also affects the oxygen. That gives us 5. Over here we have 4 times 2, so we got 8 oxygen. So total on the right side we have 13 oxygen. Well, to get 13 on this side, we would have to put a 6.5 in here. 6.5 times 2. Well, that's not going to work. Okay? Because remember, back when we balanced equations, we were told we can't have halves in front. So what we have to do then to fix that problem is we have to multiply the entire equation by 2. So our final balanced equation will be 2 C4 H10 plus 13 O2 yields 8 CO2 plus 10 H2O. All right, so check your answer and see if you got the same thing. If you did, great job. If not, double check, see where you might have made an error, and we'll try on the next one. Let's go to the second practice problem. Okay, for this one, it wants us to write the balanced equation for the combustion of strontium. So again, take a moment, pause the video, and go ahead and try that yourself on some paper. Alright, so let's check our answer. Strontium is SR. It's the element. Combustion means we are combining it with oxygen gas again. Okay, so we have an element, not a hydrocarbon, so we treat it as a synthesis. So we have, I'm going to write this up above here, we have strontium, which is in group 2, so it has a +2 charge when it makes a compound. Oxygen is in group 16, so that makes a -2 charge in compound. +2 and -2 cancel each other out, so we don't have to do our crisscross. We just write it as is. So our product will be SRO. Alright, so now we have our skeletal equation. Now we need to go ahead and balance this. The SRs are okay, one on each side. For the O's, we've got 2 on the left and only 1 on the right. So we need to put a 2 in front of SRO. That affects the SRs, so over on the left side we need to put a 2 there also. So our final balanced equation would be 2SR plus O2 yields 2SRO. So check your answer, see how you did on that one. Alright, so what's next? Well, make sure you've completed all parts of the lesson, examples and practice problems in lesson 4.05. If you still need some help, please attend one of the open tutoring sessions that we have. There is also a lesson review sheet in the Resource Center. And for this particular assignment, you are going to do a virtual lab, which will involve all 5 of the chemical reactions that you've learned in lessons 4.3 through 4.5. You can find that in the Activity tab. If you need help with that, please attend the completion session that we offer. And that is an opportunity where you'll actually walk through the lab with a teacher and be able to work on it and finish it up and submit it when you're done. Check the announcement page in the course to find out the schedule when we will have that assignment offered next. And then come and join us and we'll help you out with that. And then of course once you've got that complete, then you can submit your lab report in either the assessment or gradebook section in your course. Well, thanks for joining us today. Hope this was helpful, and we look forward to seeing you back soon.